Well, it is Thursday, and you guys are about to enjoy a long weekend, and I know that's exciting, but we do have a lesson that we're going to learn today, kind of a tricky one. But before we do, I want to go over last night's homework assignment, which was dealing with complex numbers and the different operations, obviously that we discussed yesterday. So here's number 2, and if you notice in the top right corner, I tried to show my work vertically like I mentioned yesterday in class. You do not have to do that. I just like showing it in case someone got the wrong answer. Maybe if you got the wrong answer, it's a process that maybe you would consider using to make sure that you keep your values that are like terms kind of separated and in the place where they're supposed to be. But anyways, the only trick to number 2 was that minus sign causes the 1 to turn negative, and it causes that negative 2i to turn positive. So your answer is negative 7 plus 12i. Number 4, you were supposed to distribute. And I want you guys, again, to see over there in the top right corner, you're left with 10i plus 5i squared. And then, again, don't forget, I squared equals negative 1. So I multiplied that negative 1 by 5, and that got me that minus 5. And if you notice in my answer, I put it in what we called standard form yesterday, where your real number goes first, negative 5, and then your imaginary part goes second, positive 10i. Number 6, I did all of my distributive property. When I distributed, you can see what it got me, negative 3 plus 6i minus 8i plus 16i squared. Again, I squared equals negative 1. Distribute that to the 16, you got negative 16. And now you're allowed, as you can see by the highlighted areas, you're allowed to take negative 3 and subtract 16. Negative 19 is my real part. And then, of course, 6i minus 8i gives me negative 2i. Number 8 was kind of a unique one because those kind of end up, I don't know if you guys can see, it's kind of like difference of squares. It's a little different than difference of squares because it's got i's and not x's. But when I distribute, you can see that work up there on the top right corner. 9 minus 15i plus 15i minus 25i squared. Here's the unique part of this. Those 2 in the middle will disappear. They'll cancel each other out. Of course, I squared having that value of negative 1 will cause that to become plus 25. So since all I have left is 9 plus 25, sure enough, this comes together to get 34, okay? That was the last one on that problem, or on that side. Flip it over to the back. We had 2 different types, commutative and associative, where I ask you to come up with your own version of this. Here's the key, because I know the answers will vary here. The key is this. In commutative property, you change your order. Notice how I have 3i first on the left side, but I have it on the right side. Well, I simply change the order. And here's the rule of commutative property. When it comes to addition, I don't know why I said addition. When it comes to addition and multiplication, order doesn't matter. That's commutative property. The next one, number 12, is associative property. Associative property is the way it associates. It's grouping. How is it grouped? If you notice on number 12, the way I did it is I first grouped 5i and 6i, and then I added 9i, where on the other side, I grouped 6i and 9i, and then added the 5i. So my grouping changed. That is associative property. So yours is going to look different than mine probably, but it needs to be similar in the way it's set up. Okay, the last 2 that you're supposed to do were solving by taking the square root, just like we've been doing the last couple of days. Here's the difference. Because you have a binomial squared, then it's going to mean that your solution is going to be some complex number, if especially you have imaginary solutions, which we do here. So look, I subtracted 27, I divided by 3, and then I took the square root at that point. That's when I add my plus or minus. The negative comes out as an I, and then the square root of 9, since it's a perfect square, it breaks out as a 3. Lastly, I add the 4 over, so sure enough, there's my answer, 4 plus or minus 3i. And the last one you were supposed to do is right here, number 16. Look what I did. I subtracted 9. I either divided by 1/2 or I multiplied by the reciprocal, which would be 2 over 1, or 2. So that left me with negative 18. At that point, I took my square root. Of course, you add the plus or minus. The negative comes out as an I, and then you can see over there to the right where I broke down 18. 9 is the biggest perfect square that goes into it. Therefore, it goes into it twice. And as you can see, my answer is 3i squared root 2. Then I subtract that 6 over. And like we wrote complex numbers just a minute ago above, you put your real part first. That's the negative 6. You put your imaginary part next. That's the 3i squared root 2. And it's plus or minus. So it's two complex solutions. Negative 6 plus 3i squared root 2 and negative 6 minus 3i squared root 2. Now, if you guys recall a couple of days when we had to do a video, and again, I'm apologizing that I'm having to do so many videos recently. If you struggled with one of those, please go and put an asterisk by it, and when I come back to school, we will discuss that one if you're struggling with it in order to ensure that you understand it and that you get it right. All right, hopefully the substitute is handing out to you guys now the completing the square note sheet. You guys are going to be doing a lesson that's pretty difficult today, honestly. But the note sheet looks like this. It starts off with warm up. And I'm actually going to warm you up before I warm you up. So I'm going to take you to the top and I'm going to show you. I'm going to remind you of something that I think most of you guys remember. I'm going to show you two things. One you'll remember better than the other. You remember when I showed you difference of squares? And the result of that looked something like this. And when those multiplied to each other, you got x times x squared, x times negative 4, negative 4x, positive 4 times x, positive 4x, and then positive 4 times negative 4, negative 16. And again, the unique thing about that was these are opposite, so therefore they canceled, and we were left with simply x squared minus 16. Remember how we defined that? They're both perfect squares, and they're separated by that minus sign, okay? Well, let me show you actually what we're going to be using today. Here, we're going to use a very similar concept, except I want you guys to notice my signs aren't opposite. They're the same. So I have x plus 3 times x plus 3, okay? So here's what happens on a problem like this. I hope that you remember these are the ones, and let me move this down a little bit and show you this. These are the ones that can be written also as x plus 3 squared. X plus 3 squared. This is called a perfect square trinomial. What happens is you got x times x, x squared. X times positive 3 plus 3x. Plus 3 times x, positive 3x once again. And then positive 3 times positive 3 is positive 9. So again, in this case, the difference between this problem and the previous one is we can now combine those for it to become plus 6x. But I want you to notice something. Do you notice how this is a perfect square? And so is this. They're both perfect squares. Unlike the one over on the left side, though, that middle term did not cancel. In fact, if you think about it, it was x times 3 doubled, right? Think about doubling 3x. Well, it's x times 3, 3x, doubled, 6x. This is called a perfect square trinomial. Now look, this one over here was called difference of squares. That one is called a perfect square trinomial. Well, today we're actually going to utilize perfect square trinomials in order to solve certain types of quadratics, okay? Certain types. So let me take you down here, and I'm just going to show you what I mean. Do y'all notice how this is a perfect square trinomial? Look at it. What multiplies by itself to get x squared? X. And what multiplies by itself to get 49? 7. Now what is x times 7? 7x. Double it. Did it give me that value that's right here in the middle? Well, absolutely it did. So therefore, you take the sign here, and this becomes x plus 7 squared. So if I know that I can change x squared plus 14x plus 49, knowing it's a perfect square trinomial, if I realized that I could actually take that and change it to x plus 7 squared equals 4, I can now take a quadratic that I couldn't have solved as easily, and I can now solve it using what we learned yesterday. Think about it. How do I solve this now? Well, I take the square root of both sides. Well, because I took the square root of both sides, x plus 7 is going to drop down on the left. We add plus or minus to our answer, and what is the square root of 4? It's 2. Well, then how do I get x alone? Subtract 7. So x will equal negative 7 plus or minus 2. So what does that mean my answers are? Well, just do the math. What is negative 7 plus 2? That's negative 5. And what's negative 7 minus 2? Well, that's negative 9. So my two solutions for this quadratic, using this concept of perfect square trinomials, we can actually pretty easily solve this problem for our two solutions. Let me show you another one of these, and then let me show you how we're going to use it today to solve. Here, do you notice how this is a perfect square trinomial? Look, is x squared a perfect square? Of course it is. X multiplies by itself to get it. How about positive 9? Is it? Yeah. 3 multiplies by itself to get it. What's that sign in the middle? Negative. Now let's just double check. What is x times 3? 3x. Double it. Does it equal that value in the middle? It absolutely does. So this is the binomial squared. This is the binomial squared that would give me the perfect square trinomial x squared minus 6x plus 9. So now I can solve the problem. I take the square root of this side. I am going to write x minus 3 down. I'm going to add plus or minus to my answer. And I'm going to check real quick to see if the square root of 20 can reduce. Well, let's see. Biggest perfect square that goes into 20. Divided by 10. 9 won't go into it. 4 goes in it 5 times. So this 4 becomes a whole number 2. Remember, perfect squares get to break out, but that 5 gets trapped inside. So this becomes 2 square root of 5. Last step, we're going to add that 3 over here. So the answer is 3 plus or minus 2 square root of 5. And I can't go any further with that problem because unlike the one we just did, I can't combine those, so there's no use even trying. All right, I had to get a drink. So let me show you how we're actually going to utilize this concept of perfect square trinomials to actually solve today. One, if it's possible to take a quadratic equation and create a perfect square trinomial, we're going to do this called completing the square. Now, I'm a little different than a couple of people. One, I have stipulations. I have stipulations for where completing the square is worth it versus when it's just absolutely not worth it. And my stipulations are these. Once you've done step 2 and you've divided both sides by a, if there is an a value, I like to check the b value. I like to check b. If b is not even, then I don't mess around with this because then you're going to have to deal with fractions. And if you're having to deal with fractions, in my opinion, there's a better method to solve it, and that would be quadratic formula. But if b is even after you've divided it by your a value, then it's worth trying this completing the square method. So here we go. We're going to rewrite it as ax squared plus bx equals c. Then we're going to divide both sides by a if it has an a. As long as b is even, then I'm going to complete the square by taking half of b, squaring it, and then adding it to both sides of the equation. What that will do is it'll create a perfect square trinomial that I can then rewrite it as a binomial squared. Whatever this value is, squared. And maybe I shouldn't call it A. Maybe I should call it P. And then I can take the square root of both sides and I can solve the problem. So instead of talking about it, let me just show you. Look at number 3. First of all, I'm going to get it in ax squared plus bx equals c form. And I left a little space because I saw a couple things. One, what's my a value right here? It's understood to be a 1. Does dividing by that 1 help me? No. The second thing I notice is my b value even? Yes, it is. It's 18. So this is worth trying. So here we go. We're going to take that b value, negative 18. I'm going to divide it by 2, and then I'm going to square it. I'm going to take half of it and then square it. What is half of 18? What is negative 18 divided by 2? Negative 9. Now square it. What is negative 9 squared? Well, that's positive 81. So we're going to add that 81 to both sides. Now on the right side, negative 56 plus 81 equals 25. On the right side, what I have done, and this is the key to the whole problem, what I have done is I have created a perfect square trinomial. Okay, I've created one of these, a perfect square trinomial. So what I want to do is I want to take it now and I want to back it back down to whatever the binomial squared would have been to give me that perfect square trinomial. So let me show you what I mean. Let's go back down here to this problem. What would the value have been that would have multiplied to get that x squared? Well, x. What would the value have been that would have multiplied to get that 81? A 9. So this is going to be my binomial squared. The key to the problem is the sign. What is the sign? Well, you always use whatever your middle term is, so it's minus. So we actually created a perfect square trinomial in order to back it back down into the binomial squared. And now look how easy this thing is to solve. Take the square root of both sides. So x minus 9 equals plus or minus. The square root of 25 is 5. Then we're going to add 9. So 9 plus or minus 5 is my answer. So let's break that down. What does that mean, 9 plus or minus 5? It means that one of my answers is 9 plus 5, 14. And the other one is 9 minus 5, which is 4. So those are my two solutions to this quadratic. And we use the method called completing the square. Okay? So let's go over here to number 4. Isn't it already in ax squared plus bx equals c form? But what do you notice? Well, there's an a value of 2. So we're going to do what the instructions told us to do. We're going to divide the whole thing by a. So what is 2x squared divided by 2? Well, that's x squared. That's what it needs to be. Your a value has to be 1, which we've now made it. What's negative 16x divided by 2? Negative 8x. That's an even value, right? If it's even, I can do it. If it's not even, it's not worth it. And then finally, what's negative 30 divided by 2? Negative 15. All right, so here we go. We're going to solve this thing by completing the square. We're creating a perfect square trinomial so we can then rewrite it as the binomial squared. So we take the b value, negative 8, divided by 2, and square it. Take half of it and square it. So negative 8 divided by 2 is negative 4. Negative 4 squared, negative 4 times negative 4, is positive 16. So you add that to both sides. We created, right here, we created a perfect square trinomial. So what's the binomial squared that will that we can break it back down to? Well, what multiplies by itself to get x squared? X. What multiplies by itself to get 16? 4. And what's that sign in the middle? Minus. So this is the binomial squared that would have given it. So look at the right side. What's negative 15 plus 16? That's a 1. So now, last steps, we take the square root. So therefore, x minus 4 equals plus or minus. Remember, you add that to your answer. 1 is a perfect square. It comes out as a 1. Then we add that 4. So my answers are 4 plus or minus 1, which means one of my answers is 4 plus 1. That's 5. And my other is 4 minus 1. That's 3. So my solutions are x equals 5 and x equals 3. And that's how you do it. Hope that makes sense. Now, let's keep on going. I want to show you a couple more. Look at this thing. So, remember, it's in the right form, right? So I'm going to divide by 4, the whole thing. So this becomes x squared minus 2x. But over here, look, what is negative 3 divided by 4? Negative 3/4. I personally, because of that negative 3/4, even though the b value is even, to me it's just not worth it. I would rather solve this kind of problem dealing with fractions. I'd almost rather solve it using quadratic formula, which we're going to talk on Monday. But anyways, I will show you this one because it does work according to the rules I told you. Your b value is even, so I'm going to take negative 2 divided by 2 and square it. Well, negative 2 divided by 2 is negative 1. Square negative 1, well, that's positive 1. So I'm going to add 1 to both sides. So I'm going to back this perfect square trinomial we just created into the binomial squared that gave it to me. So here it is. We've got x and 1. What's the sign in the middle? Minus. And then on the right side, negative 3/4 plus 1 is 1/4. I'm going to take the square root of both sides, which I need to add what to my answer now? Plus or minus. And since 1 and 4 are both perfect squares, it comes out. 1 comes out as a 1, 4 comes out as a 2, right? Square root of 4 is 2. So the last thing we're going to do is add 1. So my answer is 1 plus or minus 1/2. So what are my two answers really? 1 plus 1/2 is 1.5. And 1 minus half is 0.5, 1/2. Okay, look at the next one over here. Again, it's not in ax squared plus bx equals c form. So I'm going to move that negative or that 8 over by subtracting it. But I want you guys to notice this question. When I divide by a, 3, that's going to be x squared plus 10³ x equals negative 8/3. Look at that b value, guys. It's 10/3. I am not going to do completing the square with this problem. Not going to do it. I refuse. I just will not try. It's not worth the time and effort when your b value is not even. Okay? Just not worth it. So let me do a couple more of these. I want to do, really doesn't matter. All of them are good problems. Let's do 7, 8, and 10. Okay, and I'll go pretty fast so you guys have some time. With number 7, let's take that x squared plus 16x, leave it on one side, and let's take that 21 over to the other side by adding it. What's negative 5 plus 21? 16. All right, so here we go. Is my b value even? Yes, it is. So I'm going to take that 16 divided by 2 and square it. What's 16 divided by 2? That's 8. Square 8, that's 64. So we're going to add 64 to both sides. We're completing the square. We're creating a perfect square trinomial. Now on the left side, what was the binomial squared that would have given me that? Well, x times x gives me x squared. 8 times 8 gives me 64. And what would that sign need to be for that middle term to be a plus? It would need to be x plus 8 squared. And then that equals 16 plus 64 is 80. So, like we've done the last couple of problems, take the square root of both sides. Because we take the square root of both sides, we add plus or minus to our answer. 80 can be broken down. Okay, think about this. The biggest perfect square that goes into 80, divided by 2 is 40. 36 won't. 25 won't. 16 will. It'll go in there 5 times. So the square root of 16 becomes 4, and the 5 gets trapped inside. So we're left with x plus 8 equals plus or minus 4 squared root of 5. So we subtract that 8, and negative 8 plus or minus 4 squared root of 5 is my answer. I can't go any further with this answer because, unlike those last ones that we did, you can't add these values to each other. You can't subtract these values from each other. They just have to stay in this form. So that's number 7. Let's go to number 8. Number 8. So it's in the right form, but look, a is 3. We got to divide by 3. So that is x squared minus 10x equals, let's see, what is that? My brain is 23. 69 divided by 3. So is my b value even? You betcha. So let's take that b value, negative 10, divided by 2, and square it. That's how we complete the square. Take b divided by 2 and square it. Well, 10 divided by 2 is negative 5. Negative 5 squared is positive 25, so we're going to add 25 to both sides. So we're going to break this down into the binomial that would have squared to give me that perfect square trinomial. So what times what gives me x squared? X. What times what gives me 25? 5. And what's that sign in the middle? Minus. So x minus 5 squared would have given me the perfect square trinomial, x squared minus 10x plus 25. Now on the other side, 23 plus 25 is 48. So we're going to take the square root of both sides, and that's going to leave me with x minus 5 equals plus or minus. Now 48 will too break down. I know 16 goes in there 3 times. So that becomes a whole number 4. So here's my answer. Plus or minus 4 squared root of 3. But I'm not done yet because I still have that x minus 5. I need to add it. So x equals positive 5 plus or minus 4 squared root of 3. Okay? It's a lot to it, but I think you guys can do it. Last one. Notice it's not an ax squared plus bx plus c. We actually have to swap sides. So let's do that right off the bat. 4x squared, I'm going to subtract 16x to bring it over here, and I'm going to subtract 76 to bring it over there. I'm going to divide by a. What's a this time? 4. So x squared, negative 16 divided by 4 is negative 4x, and negative 76 divided by 4, probably should have I think it's negative 19. Yeah, it's negative 19. Now, is b an even number? Yeah, it's negative 4. So negative 4 divided by 2 squared. Well, negative 4 divided by 2 is negative 2, and negative 2 squared is positive 4. So we're going to add 4 to both sides. So what is that binomial squared that would have given me x squared minus 4x plus 4? Well, it's x and 2, and the sign in the middle is minus. So x minus 2 squared would have given me that. Well, on the other side, negative 19 plus 4 is negative 15. So this is going to be the first answer we have that has an imaginary solution, a complex number. So we take the square root of both sides. So x minus 2 will equal plus or minus. How does that negative come out? As an I. And how about 15? Can you pull a perfect square out of 15? No, 15 is not a perfect square. 5 goes into it, but not a perfect square. 3 goes into it, but not a perfect square. So it stays in the radical. So the last thing, add that 2. So my answer is 2 plus or minus I times the square root of 15. And that, you guys, is how you complete the square. Now, I know that it's got its challenges. I would not put it in a category that I would say, oh, well, that's easy. I don't think it's easy. But I do think it's doable. I think you can do it. So I'm going to give you guys a homework assignment, and I think that these will all work out, the ones that I give you. So on the front side, I want you to do, here's the worksheet that hopefully you're going to have really soon if you don't have it already. And then you can leave this video up for a minute so you can get it. I want you to do numbers 2. I want you to do number 4. I want you to do number 3. I want you to do number 6. No 6. No 6. No 6. Scratch 6. I don't like the fraction. So forget 6. I want you to do number 5. Keep on cruising to the back side. I want you to do number 10. And I want you to do number 11 and 12. So that's 1, 2, 3, 4, 5, 6, 7. So here it is one more time. Number 2, 3, 4, 5, 10, 11, and 12. I know it's kind of scattered, but I looked at those pretty quickly. There's a couple more that work. But like, for example, number 8 I don't like. Number 7 I don't like. Number 9 would work fine. Number 6 would be a little tricky. So let's keep it 2, 3, 4, 5. So 2 through 5, and then 10 through 12. 2 through 5, and 10 through 12. All right, well, hey, I hope you guys have a wonderful long weekend. If I see you tonight at our parent-teacher conferences, I hope that your parents are not too mad at your grade. So y'all have a great one, and we'll see you before you know it.